Good morning, everyone. Welcome to another episode of Xa Talk Show. I haven't seen you guys for a while. I haven't done a talk show in the past 2 days. So, what we gonna do? The spice must flow. The thing. The interesting thing. Like when you ride a bike with your friend to some place, you don't want to stop. Or if you are running marathon, the like you can go slow if you want, but never stop, because stops makes a huge difference. Like if you stop for 10 seconds, your friend will pass you, far ahead. So that's an interesting thing I observed. Doesn't matter what thing you are doing, running or bicycling, obviously in a marathon competition, you know the moment you stop doing something, it makes a huge difference. uh, it doesn't matter as much if you if you are slower. Good morning, break the loop, haven't seen you for a while. Yeah, so the spice must flow. Have you seen the movie Dune? That phrase is from that movie. So how have you been doing? So today I'm going to do I'm thinking I'm going to do two things. One is live coding of emacs lisp. There is some command I like to modify. So let's see, xa start command log mod. Okay, so this would be good for any of you, learning emacs or emacs lisp. Then I think I'm going to do a JavaScript live coding, which is, let's see, JavaScript live coding. This is my talk show page. I have some links here. Yeah, Celtic knots. Let me show you. So here is the page. So I'm going to do Emacs Lisp coding and Celtic knots. Now I'm going to code JavaScript, and I'm going to create this thing, this animation. This will actually take 40 minutes, so I'm not sure, we are going to cover all that. Just then the other thing, so Emacs Lisp coding, JavaScript coding, then just random. Ask me questions, because I don't have a goal. Live dashboard. So, okay, so let's see. Should we start Emacs Lisp coding? Do you use Emacs break the loop? I think maybe a little bit, not much, or so. So let me just talk randomly about this. You see, this is axolotl. Axolotl. This is a creature in I think in Mexico, some lake in Mexico, and this creature is well known for one thing. That is the regenerative abilities. Like you can cut the limbs off, even part of the brain, they will regenerate. I mean, they are the most um, they are the creature with the most regenerative uh, abilities. That's interesting, because imagine if your limbs is cut off, your hands cut off, and you can just grow it out again. That's fantastic. So that's one of the dream of humanity. We like to have that. So this creature is very interesting in that respect. I think I learned about this creature in the science fiction Dune, and that is epic, because they mentioned this creature. Actually, it's very deep and dark. They mentioned this because of a womb, I think. So there's a thing called axox axolotl tank, I think. Let's look it up. let's see, tank, axolotl tank, housing in captivity, no. Okay, no, the, wait, not tank, but dune, okay. Okay, so they have a variation of spelling, so it's called axolotl tank. So the spelling is different. So this is part of the universe, the Dune story. It's fascinating. You might check it out. So and by the way, I also learned this meme facial expressions. It's called a hagao, and this thing. Oh, I think you cannot see it. Let me move it here. Okay, so this expression mean is called a hagao. It's pretty much. I'm not going to describe it, but and there's a history of it. It's from Japanese comics. Um, since 1990s. Okay, well, let's start coding Emacs Lisp then. Yeah, let's start to do that. And the command I want to call is, let's see, extract URL. So let's go to a page, for example, computing blog, showing browser, and there are several interesting things. But okay, let's go to JavaScript. So JavaScript in depth, you see, so this page, there are several links. No, okay, I'm gonna open that page, and you see basics. So this section corresponds to this source code in HTML. And suppose I want to get all the links, of this block of text. So I have a command. You can just call it like that. You see, the command is called xar html extract URL, and here is the result. Result is automatically in the clipboard. So I open a new buffer, paste. You see, I can get all the file path of the URL. Now there's a feature of this function command. That is, if I call universal argument first, then it will get the full path of each of the file. For example, let me show you. So Control U, then I call my command. You see, that's the result. So I go here, paste. You see, now you got the full path of each of these value of href attribute. Okay, so you have this option to get the full path. But what I think is more intuitive is get the full path by default. When you press Control U, then you get the short path. By the way, this command works if you have a URL that is start with HTTP, not local link. That will just return that HTTP full link. For example, let's see if I can try that. For example, here's a link. I call the command, and I go here, and what you got is that. Okay, that's not a good example because that's not a HTTP link. This starting with a double slash. That is I think it's a new feature around 10 years ago in HTML. So this is called basically what that means. What this URL means is that it'll just link to HTTP if your current page is using the HTTP protocol, and it will go to HTTPS if your current page is using the HTTPS protocol. So that's because that was the issue for people. But anyway, so back to the emacs command. So I want to modify this command xar html extract URL. This command is, let me show you the URL. So here is the source code for the command, and here is the URL. And if you like to use this command, you can just copy it and put in your Emacs in it. Okay, hi guys. So say something. Okay, so today we're gonna do Emacs Lisp JavaScript live coding, and any random questions you have, just post in type in the comments. Okay, so back to Emacs. So we have this command, so you can use, and now I want to modify it so that by default it will copy the full path. So I guess first of all, copy this new buffer, paste it here, xar emacs list smart, save it as some temp name, okay, .el. Okay, then we're gonna just modify this file. So the task is, this command extract URL in a file of a selection or text block. If you press Control U first, it will create the full path. So what we want is the default behavior to be full path. So what we need to do is so I'm wondering if I should explain the code, because I guess for most people, most people don't know Emacs Lisp, so this is incomprehensible. Anyway, no, I think, well, if you have a question, okay, if you don't know, if you like to know, then just type the comment. I think I'm just going to directly code it, because to explain the code from the ground up, that will be too much. That will be, take a long time. So anyway, so get current prefix aux, that will, the value of that variable is what is the value of when you press Control U. So that's a universal argument. So we are getting current prefix arg. So I want to modify this. Okay, so when full path. Okay, so I think, I think here's what we're gonna do. This is okay. There is a lot to explain, but if I do not explain, I don't think anyone understand. Very few people understand a thing. Then it's going to be boring. But anyway, so this function takes 3 arguments. The reason it takes 3 arguments is that so that if you are calling this function in Emacs Lisp, not interactively, but in Emacs Lisp code, this is very useful. So you can call the function by, for example, 1 to 1000, okay, or to 800, okay. You can call this function just like that, and it will return the URL in a list, in the selection from cursor position 1 to cursor position 800. So that's how you call this command in Emacs Lisp. But if you are calling this command interactively, where does Emacs get, these arguments? Well, the way they get the argument is due to this interactive clause. You see, that is the purpose of the interactive clause or function. It's actually not a function. I think it's a macro. Anyway, the interactive thing, the purpose of that is to generate, by some means, to generate the arguments for the function. when you are calling this function interactively. For example, I go to a HTML page. uh, I want to extract this URL path. So I can just press a key. I call the command. You can see on the left side, HTML extract URL. Then I can paste it. You see I got the path. So when I call the command HTML extract URL, I didn't give it any argument. How does Emacs get the argument? You see, because this function is supposed to take two arguments: begin position and end position. So where did Emacs get the argument? So Emacs has a mechanism. When you define a function or command, Emacs has a mechanism that is by this interactive function call. In this interactive section, you can specify, you tell Emacs how to get the argument for the function when user calls the function interactively. So here's a code. So you see, we check if there's a region, user region position P, then you set P1 and P2 to beginning of region position and end of region position. So P1 and P2 are two positions, like two numbers. That is a starting position and end position of the selection. If you have, if use region P is true, returns true. That basically just means if there's a selection. Selection means a text selection. So if there's a selection, then let P1 and P2 be the beginning and end of position of a region. But otherwise, we say, you see, we search backward by empty lines or tab space, basically by two empty lines, two empty return characters, such as this, or over here, or over here. It's basically every beginning of a paragraph. So we move the cursor to there. Then we basically set P1. Then we move the cursor to the bottom of the next empty line. Then we set P2 here. So basically, if there's no cursor position, then this command will take the current block of text the cursor is in. A block means separated by empty lines like this. So that's how it got the P1 and P2. P1 and P2 is the beginning and end position argument. And once Emacs got that, those numbers, it will just pass it to the argument, begin, as first two arguments. So that's how this interactive block works. So let me summarize. So in the interactive block of Emacs lisp command is designed so that when you call a function, the function require arguments, but when you call a function interactively, by a key press or whatever, then you need to fill the argument. So the interactive function is a mechanism such that when you define a function, you can tell Emacs how the function should fill the arguments when user call this function interactively. So that is what interactive is for. So what is it that I need to do? We need to let me. So I need to explain. So we explained interactive. I need to explain how you get the universal argument. Okay, so I think we changed the nature of this talk a little bit, because I was going to just call this emacs list command, but I think few people will understand that. So instead of we start to explain some of the basics of emacs list. So let's go to emacs blog. Okay, so I have a emacs list tutorial here. You can buy it if you want to support me, like my stuff. You can buy the whole entire emacs list tutorial. So, but what we're gonna do is we have explained the interactive form. So there's a tutorial page here you can read. It's more precise and detailed. So that is the interactive form. Now the next thing we want to explain is the universal argument. Now you already know. Let me show you a emacs command that use. Let me explain what is the universal argument. So in emacs, when you call a command, let's say I'm in diet, the directory utility to show the directory. So I move the cursor. Now there's a command. Let me call it. The command is called diet copy file name as kill. You see, so what does that command do? That when you call that command, basically it will copy the file path of your cursor wherever your cursor is on. For example, let's say my cursor is over here, and let me call that command. So the command has a shortcut W, so I just called it. You can see it prints a message here, but now it's on the clipboard. So I open a new buffer, I can paste it. You can see that's a file name. Let me try another example. So I move my cursor here, then I call the command W, then I paste it. You see, I got this file path. So that's a very useful feature in Emacs when you want to get a file path. Now, but notice this file path is not the full path, because the full path will be like that, the full directory path. So what if you want the full path? So this command diet copy file name as kill. This command has a feature. So if you want to get the full path, what you do is you call the universal argument first. That's a Emacs thing. So what you do is you press Control U. So I press, for example, let's move my cursor here. Okay, Control U. Okay, let me try it again. Control U. Okay, now actually let's start over. Control U. Okay, now I call the command W. Press the key W, which calls the diet copy file name as kill. Okay, now I call that. Now I go to the buffer and I can paste it. Oh, I made a mistake. So instead of Control U, you have to press. Let's try this. Control U 0, then W. Okay. Now paste it. You see, you got the full path. So what's going on? So basically, the command copy diet copy file name as kill. It has options to let you whether you want the full path or not. But how do you invoke those options when you are calling this command directly, especially if you are calling it by a key, a keyboard shortcut? So Emacs has a mechanism, another mechanism, that is to let user optionally fill the arguments to the command. So in the case of the command where is it? So in the case of the command diet copy file name as kill, it has options to let you copy full path. But in order to access those options, what you have to do is you have to press Control U first, then press 0, then then press the key to call the command. That's how you give it the option. Now, this is a general mechanism. This works for every emacs command. So, in other words, anytime you call emacs command, you can always try to press Control U. You know, that gives it some option. And but however, not every command supports that. So in other words, Emacs has this mechanism built in to supply arguments to commands when the command is called interactively. So Emacs has this, this feature built in. But however, not every command uses that feature, because for many commands it doesn't make sense to have lots of options. Um, so anyway, so that is a universal command. Okay, so universal command is to call universal command, you just press Control U, then you call the command, whatever command you want to call, such as emacs something, the command name, or by a keyboard. And also the Control U can be followed by digits like 0 to 9. So anyway, so that is universal argument. Let me see. I have an article here. Well, I have an article here about get universal argument. So this, so I think, is it confusing? Because we just talked about two topics that are very, very similar. One is interactive form, and one is a universal argument. Both of them are related to passing arguments to a command when the command is called interactively. Yeah, but you see, they are different in a way that the interactive form, when you call the interactive form, the purpose of the interactive form is a emacs lisp function. It's a emacs lisp construct that tells Emacs how to fill the arguments of a function. But the universal argument is actually slightly different. It's not about filling in the parameters of a function, but rather it's about extra options of a function, like variant behaviors of a function. So whenever you create an Emacs command, typically you have the parameters, the arguments that tells the function, what to do, well, not what to do, but the input for the argument for the function. But sometimes you want, so typically in every programming language, if you want a different behavior of a function, you create a new optional argument. You just pass the argument, and you'll signify to the function, what to do. But in Emacs, there is another way, like a new way. So you could, just like every programming language, you could create a new parameter, optional parameter, that tells the function what variant behavior to do. But besides that, Emacs has a different way, and that is the universal argument. So, and this universal argument is when you call a function interactively, you can press Control U first, then give it a number. So that's how Emacs find out, whether if you want alternative behavior of some command. So does that all make sense? Let me know. So we explained emacs this interactive form, and we expand universal argument. So now, so what is the next? Next, should we continue to work on this, modify this emacs lisp code? Wait, am I still broadcasting? I think I am. Okay, good. Okay, so let's see. So let's continue modify this this command then. So this command HTML extract URL. Now remember, it takes a universal argument, so that if you press Ctrl U first, it will copy the full path. So the way this function works, let me explain. Yeah, since we explained about arguments and options a lot, let me explain how this function works. So the function, as a emacs lisp arguments, it parameters, it takes three parameters: begin, end, positions, and a optional parameter called full path. And the value should be either true or false. So if it is true, then it returns the full path of the local file path in URL. If it's false, then just the file name, not without the directory name. So we have these arguments. It's all nice, it's very nice. It's and you can call this function in elisp like this too. So it has these options. And how does Emacs get these arguments when you call interactively? We have explained that that is done by interactive form. Okay. Now, what if user call this interactively and they want the full path? They want the full path. That is, they want to be able to pass the optional argument true, as the third argument. So that way is done over here. You can see the code over here. So it's part of the interactive form. So the interactive form basically automatically returns this list. So this list contains three items: P1, P2, and current prefix arg. The P1 and P2 are the beginning and end position. And the third argument, current prefix arg, is the full path parameter. So the value of that is true or false. So what is the current prefix arg? Now that is a built-in function. Basically, if user call this function with Control U, that is the universal argument. If he press Control U first, then the current prefix arg, the value of that will be true. Otherwise, it will be false. So in this way, when we have this interactive form here, and it returns a list, you can see it returns a list here. So the list contains three arguments. These three arguments corresponds to the parameters of this function. So this is how Emacs gets those arguments. So let's look at the documentation for current prefix arg. So you see its value is nil. Documentation, it says the value of the prefix argument for this editing command. And it may be a number, or maybe a symbol, negative sign, or just a minus sign, blah blah blah. That's the details. But anyway, this is called universal argument in Emacs. So this is how this command gets the arguments when user calls it interactively. Okay, that explained that. So the way we want to modify, so you see, we want to modify. Oh yeah, so now we understand this. It's very easy to modify this. All we have to do is to not this argument. That just boolean turn it reverse the boolean value. So if it's true, return false. If it's false, return true. Yes. So so that's so easy to modify now. So let's see. But we have to modify the name though, because we just reversed the meaning. So change full path p. By the way, the name dash p at the end, that is Emacs convention for any variable or function that returns true or false. So if you have a function that returns either true or false, you want to name it with dash p at the end. The p stands for predicate. Now predicate came from logic. Predicate basically means a statement or sentence that is true or false. So anyway, so function. So we want to change the name to full path p, then change it to not full path p. Okay, that's what we want, because we just changed its meaning here. So okay, now it's done. Let's evaluate the buffer so Emacs knows the new definition of this command. Now let's go back to a HTML file and let's test it. So go to JavaScript blog. Actually, go to JavaScript website, which is JavaScript in depth. Go to the basic section. So we want to extract URL of this text block. So let's call the command, call it, and we got a full path. That is correct. Excellent. We open a new file, paste, verify that it is all full path. That is correct. That's great. Now let's try press Ctrl U, then call the command. Okay, now that works too. It returns just the file name. So that's a success. So that is successful. So what we do is we copy this command, copy it, go to my XHTML mod, paste it in, remove the old code, save it, because this command XHTML extract URL is part of my XHTML mod. You can try if you like it. So that completes our first topic, and yeah, that is actually good. I think it went smooth. That completes our first topic of live Emacs coding, and we explained. So let me summarize. We explained the interactive form, and we explained the get universal argument. Fantastic. So what is the next topic? So guys, what will be the next topic? Type something. Let me know. I'm drinking tea. Cheap tea bags. So the next topic, let's go to close that. We don't need it. Oh, okay. So let's go to the next topic. So get universal argument. Celtic knots, Rancette tiles, combinatorial patterns. This is okay. So I'm thinking, maybe we stop coding for now. So I'm just going to chat randomly. Like maybe interesting things. This one is about math. Now this thing you see here, it's it's isn't that beautiful? That's called Rancette Tiles. It's named after some guy Rancette something. You can look it up on Wikipedia. There's a Wikipedia page on Rancette Tiles. But anyway, it's a technique to generate interesting patterns. As you can see, all you have to do is you start with a square, and okay, this is a good time to use digital pen. Like maybe I can play with that. I have a digital pen. I'm not sure this will work, and it's not connected. So let's try. You see, let me show you. So you see, I got this thing. This is oh yeah, let me mention this. So it might be fun for you guys to buy it. It's $60, or was it $40? Oh yeah, so this let me talk about something interesting. Okay, Rancette tiles. Okay, you know what it is, right? So let's go to keyboard. Keyboard is a fascinating subject. Okay, you can go to my keyboard blog. Let me show you. Uh, there are some news about keyboard. Yeah, let's talk about keyboard. So this guy created this do-it-yourself keyboard. This guy is on Twitter. Now I suppose he's anonymous. So he created this do-it-yourself keyboard. So his name is shipping, something like that. So it's interesting. It's a ergonomic keyboard. It's similar to the one I am using. You see the one. This is the keyboard I am using. This is called Kinesis Advantage 2 keyboard, and you can see it on my blog. Okay, so you can see it on my blog here. That's that keyboard. Um, but this guy's creation is something similar. Yeah, so let me talk about this Kinesis Advantage. Now this, so yeah, let's give a history of this ergonomic curved surface keyboard, concave surface keyboard. So the first one, as far as I know, I think it's actually true. The first one invention of this keyboard is called Matron. Now they began in 1977. I think it's a first. I've seen references, kind of. I'm not, I think I've seen semi references saying that there's a IBM one before this, but I wasn't sure of that. So as far as I know, this is the first one, 1977. We are talking about the curved surface keyboard with a curved ball surface for the fingers keys. Why that? Because this way it's more ergonomic. Like when you put your hand on the keyboard, you see. Let me show you. You see, this is my. As you can see, let me try this. Okay, I'm going to try to make the video. I'm going to try to make the video full, so I might blank out for 30 seconds. So bear with me. Check. So my audio is back. Let me turn on the video. This video. Let me turn on the video. This this software OBS is pretty good. It's an open source software, but sometimes the video settings and audio settings, they get corrupted or crash, something like that. So you can see that is my keyboard. Now that's a oops, let's do that again. So modify big. Okay, now you can see me, I think. So anyway, so that's my keyboard. That's my mouse. This is fantastic with a spin wheel, infinite spin. I showed it many times in my video talks. So, oh yeah, so I was going to say, so if you look at the keyboard, so this is curved. You can see that it's going down. So when I put my fingers there, you know, on a normal keyboard, it would be like that because it's flat. On normal keyboard, your wrist bends up. That's no good. So that's why they invented this curved concave surface curved keyboard. Which is ergonomic. So if you type a lot, that is good for you. So in the beginning in 1977, this Motron uh, guy, they have a history on their website. Stephen Hopday, Lillian Mote. I think she designed and invented it. And so anyway, so this is the beginning. It was in the beginning. It was for disabled people. People who have problems, who type and have hand injuries. But anyway, this is fantastic. If you are a programmer or a writer, you use keyboard a lot. But this one is very expensive, though. This Motron is like $500. No, it's not. So it's too expensive. So what do you want? And the one I have is this one, Kinesis Advantage. Now they began in 1990 or 89, something like that. Basically, they borrowed. The story I heard is that they tried to the Motron is patented, but I think Kinesis talked to them and something didn't work out. So Kinesis just created their own, basically just copied them, but removing all the number keys in the middle. You know, I don't think you can pass patent by doing that because essentially you are still borrowing other people's invention. But I don't know what's the deal between them, legal deal or how they work things out. But anyway, Kinesis came out with this, um, you know, also concave surface keyboard with a bunch of keys in the middle. So it's very good. I've been using it. Uh, this is about $320. Now, don't quote me on the price because price changes all the time. Like sometimes you watch some video, they say, "Oh, this is $100." It turns out 200, or it turns out $50. Then people get annoyed. So anyway, because price actually changes all the time. But anyway, if you like it, buy it on my website links. Just search for Xali Kinesis Advantage. So this keyboard is very good. It's designed. So I have explained why the concave surface keys. Um, I can show you some typings on it, but actually I have already videos about it, so you can watch it there. So that's that. So you have these commercial versions of concave surface keyboard, um, but people started to build their own today. So let me show you. For example, do-it-yourself keyboard. So beginning with 3D printing, like 5 or 10 years ago, it became popular. People start to create their own stuff. So you have this one, which is right now it's the most popular, do-it-yourself keyboard. It's called Tactile, and if you are inclined, you can build it yourself. You just buy the parts. But however, it's not going to be cheap neither. It's like he told me it's going to be like $350 or $400. Actually, it'll cost you that much. Then you have to build it yourself. Soldering. Buy the keycaps, buy the parts, 3D printed, and soldier it, everything. Uh, he doesn't sell this, so this guy created it. This is a great guy. He is a emacs user. He is also a Clojure lisp coder. He loves Clojure. By the way, he's also a Mathematica user. Mathematica is my favorite language. He's also actually he used of all the people I know, programmers, because in the industry you rarely see a programmer that uses Mathematica. I mean, maybe they have used it in college, for a month or something, but that doesn't count. You have to like use the language. And so this guy Matt Aderith, he actually codes Mathematica. So he's a fan of Clojure and Emacs as well. So he created this keyboard. So you can go to his website. This GitHub. You got all the information, which the parts you need to build this keyboard. So this is one example of do-it-yourself keyboard with the concave surface. But then people started to create more. I mean, I'm not sure Tactile is the first one. Well, at least it's the first that's most popular. Okay, it's one of the first. Then you have also this Tactile Manuform, which people created. By the way, so today there's like tons of them. So there is one called Manuform keyboard, which kind of look like that. The distinguishing feature of the Manuform keyboard is these thumb keys, these weird thumb keys. So, but I don't have a page for the Manuform keyboard, but you can search the web. You'll find it. So someone created this Manuform keyboard. Let's see images. Those are not all these are not it. In fact, most of it is pictures for my website. So you have to actually go to Git. I guess. Yeah, those are not Manuform. You have to go to okay, here, GitHub Jeff Graham Manuform. I think this is the one. He doesn't have pictures. These nerds, why can't they just put a picture? You need a picture or two. This is so people can understand it. Because these nerds, my complaints about these nerds, these open source or Unix, they are unable to think. They are unable to think properly when it comes to user interface or convenience for users. They are unable to. They are the typical stereotypical nerd of the engineer, like inflexible, like unable to comprehend things, well, except technical things. So Manuform keyboard, they don't have a picture. Well, you can find it somewhere. But anyway, so someone combined the Manuform keyboard design, the thumb keys, with the Tactile keyboard design. So they combined them. So they created this Tactile Manuform keyboard. So you can. I think there's also a GitHub page you can go to if you want this. So you have Tactile Manuform. Then there is more. So people have this one is from Japan. The Japanese have created this Colloseum Keyboard. Now, I don't think this one is based on tactile. Yeah, I don't think so. You can see the thumb keys arrangement are, and the curves are very different. They may be inspired by it, but anyway. Um, so this one made by some people in Japan, Japanese, and you can go to there's a Japanese website. You can buy the parts. I have no idea how these thumb keys supposed to work. I can't imagine. So I suppose this with this keyboard, normally like on my Kinesis, even the thumb keys you press it down. So on this Colosseum keyboard, I suppose you kind of press inward. I'm not sure how I feel about that. I cannot imagine it's that good. But you don't know. You actually have to try it to know. And here's interesting. They got a spinner on a keycap. I really should have. I'd love to have that. Uh, you know, a spinner on a keycap. So some Japanese created that. Then this guy created this keyboard. Uh, he said he's going to. This is a prototype. He said he's going to clean it up and stuff. He sent me messages on Reddit, but I don't think it's done. It's been a year now. Yep. So anyway, so there are these variations of keyboard, with this concave surface, and this one is the most spectacular. I'm not even sure how it works. This ergo warp keyboard. I'm not sure what that ball is for. It looks like a trackball, but I can't imagine how you use a trackball like that. I don't even know where do you put your fingers on this thing. So anyway, ergo warp keyboard. So yeah, so there are all these variations, people created. So that is why, so this one is a new one. You can see this one is a new one. Anyway, so that's about keyboard. Let's see how many people are watching. 5 people. Okay, about keyboard. I think that's about it today. Um, the JavaScript we'll do another day then. So we have lib coding of emacs lisp and concave surface keyboards intro. Okay, so that's today's topic. So thank you guys for watching. Possibly I'll do another one, the next one coming up in maybe 6 hours. So see you guys. Have a good day. Good night. Break the loop.